Okay, guys, we've got a couple more, so let's start. So first of all, good afternoon and good morning to everybody. Appreciate you making some time to join us here. My name's Dave Armstrong. I'm the principal CCLAS LIMS consultant with this team. And this is one, or in fact, this is the final in a series of presentations that we've put together to highlight the CCLAS EL Velox solution. Today, we're going to be considering the use of the Velox model to allow calibration events to be created, stored, and managed. Now, this is delivered as we've said, as part of the CCLAS EL Velox solution, but this and all the other webinar presentations we've done along this line, all of this functionality can be retrofitted into existing CCLAS EL systems. Okay, so before we commence, I would just like to briefly introduce the webinar system. The intention here is that we'll allow any questions to be asked at the end. So if you could please defer any, just in case there are any. And the way that you guys can ask a question is using the icons that you can see on screen from your interface. Just first of all, use the raised hand, press that icon, and that will indicate that somebody wishes to ask a question. And then you can use the chat dialog, which is also highlighted in red, and that will allow you to ask the question. And if we have time, we'll certainly do so. Keep in mind that if you've got any questions, we can answer them at any time. Just communicate that to us. There should be no problem whatsoever with that. Okay, so let's move on. The first thing I'd like to do is just introduce our parent company, which is Datamine, for those who may not have come across it. Datamine is a global software development and service delivery company. It has an exclusive focus on the mining, minerals processing, logistics businesses. We have a significant development team also spread around the world, and that is supported and represented by an equally strong team of industry specialists. Okay, now CCLAS is part of a suite of software packages that I'm just going to briefly mention now. These are called the Intelligent Mining Solutions, as you can see, and we have 4 products. The one that we're interested in today, CCLAS, is our LIMS product. And we have Mindscape, which is our modeling data mapping application. We have MindMarket, which is our enterprise solution for inventory logistics and also for marketing. And finally, we have the production accounting system, which is the metal accounting software. Now, these are all part of the same one big family, really, and they're all integrated. So it's a fairly significant solution that we can offer. Okay, now just one more word about CCLAS itself. As some of you know, it's closer to 40 years in terms of its development time, and it's very widespread around the world, 75 countries, as you can see from this slide here, large numbers of users, and it's those users and the experience that we've gleaned from those users that's allowed us to put together this Velox solution, which we hope is immediately accommodating the needs of a modern laboratory. Okay, just one more. This is some of the customers that we're very proud to be involved with. It's not an exhaustive list, but these are some of them, and these ones are on. If we scrolled it up, there'd be more, of course, and every one of our customers is valued equally. Okay, so let's get down to the agenda that we're going to be working on today. So this is about instrument calibration. Now, instrument calibration itself is a very specific activity that occurs with an instrument and the software that is linked exclusively or implicitly to that piece of software. So CCLAS doesn't control instrument calibration at the instrument level, but this is about our interaction with that calibration. So how do we configure CCLAS so that it can be involved in the calibration process. Of course, any calibration, particularly in a laboratory, is about data. So how are we going to use CCLAS to hold data about the calibration that's just occurred or we've just requested? How do we effectively calibrate instruments, or how do we receive that calibration information from those instruments? And finally, how do we audit the use of calibrated data from an instrument when we're doing data capture? Okay, so with that, I'm going to start the demonstration. So I'll just kick up CCLAS, and I'll just have to shift my screen, which is always interesting. So hopefully you guys can all now see a CCLAS Velox screen. So this screen may not be familiar to everybody in terms of its appearance, but basically it's built on the CCLAS EL core. What we see here is an embellished version of CCLAS. There's some nice screen grabs on there, or KPI information, but also there's a fairly comprehensive list of items there that are in part of the core and otherwise part of what we give when we deploy Velox. So let's get straight into it and start talking about instruments and how we're going to set them up for calibration. The first thing I want to show you is the core application, which is a configuration application, but it actually stores our list of instrument codes. Now, you've seen this, anyone who's been to previous presentations has seen this already because we've looked at other aspects of maintenance, but I'm specifically interested in calibration here. Of course, if we're going to calibrate an instrument, we have to define it. We have to know exactly what it is, because we have to be able to store information against that instrument. As the example that I'm going to use today, I'm going to keep it as simple as possible. I'm just going to look at a balance, in this case, balance 1. Now that happens to be a certain manufacturer's balance, and let's go and have a look at some of the properties we've got. And I'm not interested in the core properties at this point, but some of the extended properties. In fact, I'm only interested in one in this case, and that is the checkbox that says calibrated. So we set up our instruments and we decide whether they need to be calibrated or we need to be aware that they're calibrated inside CCLAS. And for the case, in this case, we've got, yes, this one needs to be calibrated, which is useful because we need to be able to demonstrate that. Okay, so that said, the next item that I want to look at is something that we call stream maintenance. Now, stream maintenance is specifically a Velox solution to the ability to define and schedule samples. Now, one of the things we're going to have to do in calibration is we're going to have to register samples into the CCLAS system because we need to store our calibration data somewhere. So without further ado, I'm going to open up the stream maintenance. And while I'm opening up, I'll just explain that we haven't at this point done any presentations on the stream configuration, but we are planning a series of videos about more fundamental aspects of CCLAS. And this, even though it is Velox, we consider to be one of those fundamental aspects. So there will be a presentation or a recording made which details the use of this particular application. Now, when we're dealing with calibration, we're interested in standards. So I've just opened that node. And what I'm going to do next is open up the BAL-CAL, which is the balance calibration. Now, the BAL-CAL is what we call a stream, and the information underlying that, BAL1-CAL and BAL2-CAL, are stream schedules. In our case, what we've done is we've said each balance in the laboratory will have a schedule created which will define how and when we're going to register calibrators into the system. So let me just open that and I'll briefly explain what's happening here. So this is in fact a standard which is called BAL-CAL, and that has got a set of defined limits which are going to be limits which we apply in this case to reference weights that we have to put on the balance when it needs to be calibrated. What's important on this stream is that we have a job template associated with the standard, and that will define what the assay requirement is on that standard. We've got a set of masks that tell us about what job this automatically scheduled reference standard sample will go into. And you can see it's a little bit codified, but if I run the test button onto these codified items, you can see that it's telling us what they actually mean. The interesting one here is what we call the external ident mask, which is telling us this is the balance 1 calibrator, and it represents the day shift of the 20th of August 2020. What else do I need to say about this? It is scheduled sample registration, and you can see from this dialog, without having to absorb all of it, every single shift it's going to register a sample. Now, this laboratory has a 7 o'clock, 9 and 7 o'clock AM and PM shift, and we want this to happen every day. It's a 24/7 operation. And finally, there's information about what particular assays are of interest, and I'm not going to dwell on that because we'll see it when we go into the calibration job. So this is the means to automatically register calibrators into the system. I'll stop that one, and what I'm going to do next is actually register some of these calibrators using our task scheduler. And as I said, this is automated. So if I open up what's called the stream registration schedule, I can set for today, which is the 20th of August, a day shift calibration. Now, obviously this is in the task scheduler so that it will run automatically, and these samples will just be in the system at 7 o'clock in the morning. So allow me just to hit the function that will manually cause this action to happen. Let's pretend it's 7 o'clock in the morning on the 20th of August, and we'll just wait for that to complete. And while we're waiting for it to complete, I'm going to go and do something just to demonstrate what's happening at the moment. So if I open up the data entry routine, and go to capture some weights into a geology job, let's say fire assay. So this is my typical MD weight capture screen, and I'm going to now capture. So I request the balances, and we know we've got 2 balances, BAL 1 and 2, and this is the one that I'm interested in. So I'm going to kick that one off, and as soon as I try and do that, it tells me that this balance requires calibration, because we need to do calibration on this every shift at the start of shift, hence the schedule running at 7 and 1900 hours. So it tells me what I've got to do. I've got to go and find the BAL check job and capture some data into there. So without further ado, and of course this normally would be done at the start of shift. Sorry, I was just trying to close that one down. So I've gone into the client calibration in CCLAS, and I'm going to open up the balance check for August. Now, I've set these up to be in monthly jobs, and I've put both balances into one calibration job, but because of the stream scheduling, you can put them in any job, and you can set them up to be daily jobs or anything you want. So let's go up and have a look at this one and see what we've got in here. So this is what happens inside the calibration registration routine. You can see that I've got data for the 19th, and this is the start of day shift on the 20th. And you can also see that we've got information to say that the data is currently uncalibrated, and that's critical. Now, if I come in and say, I don't want to be using the balance, I'll just weigh this thing, and I type in my expected weights, and 5, which is the requirement, the capture process does not respond. It ignores anything that's put in manually. You've actually got to capture it through the balance for it to function correctly. So what I'm going to do now is start up the balance, and remember that it is uncalibrated, but because this is the calibration job, it's aware of that. So I'll select it again and select OK. And now I've got an instrument simulator that you can all see. And what I'm going to do is manually enter those weights. So the first weight that's expected for balance 1 is 0.5 gram. You can see that in the column header. So I'll put in, whoops, I better put in 0.5 gram. And I'll enter that. And then the next one you'd expect to see is a 5 gram weight. So I'll put in 5. And you can see that it's assigned it as calibrated now. You can also see that that result that we just put in, 5.0004, is on the limit of what we accept for this. The maximum accepted value, that tolerance that we will allow, is 5.004. We just made it. And by the way, these are standards, so the specifications are stored inside CCLAS. Now, normally I would move to a second balance, balance 2, or balance 2 would be in a different calibration job, but I'm just going to calibrate that one as well. The balance is still operating. So I'll go back to my balance and I'll put in a 5.4, which is acceptable. The next one for this, which this is a bigger scale balance, so I'm going to put in 10.001 and into manual data. And finally, I'm going to put in 51. And you can see that it doesn't like that. It falls outside of the tolerance. So this is telling us that something needs to happen here. This thing needs to be calibrated before it can be used in general use in the laboratory. What I'm going to actually do now is just put in the exact correct one, 50, and you can see that that one is now happily calibrated. Okay, so there's our calibration job done at the start of shift. And what we'll do now is go, I'll have to stop the balance, and we can go back to a normal workday job, which is our fire assay, and we're going to go into weight and volume mode. And what I'm going to do now is start weighing using balance 1 again. Now, let me start that and select balance 1 and begin. Now you'll notice that it is now not stopping me from doing the weighing. It's quite happy to let me continue, and that's as much as we would expect. This is a 50 gram fire assay, so let's just throw a few little bits and pieces of data into here. So we can send from the balance now, so I'll send that. We'll generate another one and send that, and I'll send that, and I'm just weighing. Halfway through, I'm going to stop and I'm going to type a couple in, and I'm going to save that data. So we all know that it's possible to manually enter data into CCLAS. There's not an issue with that. We can prevent that, by the way, and we could, if necessary, we could tie locking these data cells up to stop that manual entry being put in. But in the circumstances, if I request to toggle a screen, toggle a value on the screen, you can see there what I've asked to do is toggle to show me the calibration status of this particular job that I'm weighing. And whatever has happened here, it's clear to me as the chemist or the reviewer or the lab manager, if I go in and have a look at this, that the first 4 weights were calibrated correctly via the balance mechanism, and the last 2 were not. They were captured. There's nothing in there to say this was a calibrated weight receival. Okay, I think that's probably as much as I can say from the balance perspective, but let's just continue a little further. This applies equally to any instrument inside the system, and I've also got inside this system an XRF calibration check too, and if we open that one, I won't open it in weight mode, although we do need to weigh our samples. I'll open it in final results mode. You can see that we've got some samples for day shift the 20th, because they're also automatically generated. Now, these aren't the true calibration that you might run on XRF, albeit irregularly for an X-ray, but if this was an ICP, you might do it every morning. These are a set of standards that are going to allow the lab to continue and not allow it to continue if they don't pass for the critical elements. So when we're setting up our standards for these calibrators, we'll only set tolerances in where they really matter, and if they fall out, we're not going to allow that instrument to be used. Okay, guys, so that's our way of controlling or managing instrument calibration. I hope that's been useful to you guys and perhaps of interest to you as something you might deploy if you have CCLAS. Don't forget, everybody, to please ask anything, not just about this presentation, but any other ones you've seen. And we look forward to you joining us, at least by looking at our videos when we do our more basic core presentation of CCLAS functionality. Thank you very much indeed, everybody.